Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Enjoy! For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3, then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward one and have that 5 at the end. So the smallest odd number is 3,485. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10 or 7/10. So we can either use the calculator to work out what 1.2 cubed is, or we can do 1.2 times 1.2 times 1.2. Now if you want to use the calculator to go straight there, you're going to press or type in 1.2, and then normally there's a button that looks like this, X with a little 3, okay, and that will give you the answer. Or if you're not sure how to do that, you can times it by itself 3 times and you get the answer 1.728. This question's all about like terms, so what we can do is we can add this 10u with this 11u to make 21u. We can also add this 6v with this plus 4v to make 10v. We can also add this 10w to this minus 6w, so 10 take away 6 is 4w, so plus 4w. But we can't add a u term to a v term to a w term. So we have to just leave them be. So our answer is 21u plus 10v plus 4w. But we can multiply them, we just can't add or subtract them. So for this question we need to convert the percentage to a decimal. So to do that we get that 8.9% and we just divide by 100. And so that will give us 0.089. And so we get that 0.089. Of normally means times in maths, so we're just going to times that by 457, and that will give us 40.67. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15 multiplied by 3, which will be 45. So there will be 45 edges. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2 and it will have 30 vertices. Whenever we multiply two negatives, we always get a positive, so we know our answer will be positive. We're going to do 9 times 12, which is going to be 108, and v times v, which is going to be v squared. So we're going to start by writing 5 over 9 as a decimal, and to do that we just need to do 5 divided by 9, which will be 0.5 recurring. And to convert between a decimal and a percentage, we just times by 100. So we're going to get that 0.5 recurring, and we're going to times it by 100, and that will equal 55.555 recurring. And to the nearest percent, that's going to be 56, because that 5 will move that 5 up by 1. So we're going to start off by writing the sequence out, and what you might notice straight away is that each of the terms is increased by 2. And so we're asked to find the next 2 terms. So we're just going to keep this pattern going. So increase it by 2, that would be 20. Increase by 2 again, and that would be 22. To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table. So it'd be 10, 20, 30, and 15 times table with 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time. And all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. The lowest point on this graph is here, and that's at point 6, and the highest point is here at point 20. And we're looking for percentage change or percentage increase. And the formula is change over original times 100. So the change between the 6 and the 20 is 14. The original, the starting point, was the 6 and times by 100. And that gives us 233.333 blah 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 percent. And this 100 technically is 100% that we're timesing it by. So it says it wants it to the nearest percent, so that would be 233%. In this question we've got pounds and we've got dollars, and we're told that £1 is equivalent to $2.12, and we're asked how many dollars can be bought for £1,500. So to get from 1 to 1,500, we times by 1,500, and we're just going to do the same to the other side, 1,500. And when we do that, we get the answer of 3,180. So £1,500 is equivalent to $3,180. To get from the length of a square to the area, we square the length. To work backwards, what we do is we square root, because the inverse of square is square root. So we've got 196, and we're going to square root it to find the length. So we work out the square root of 196, which is what number times itself is 196. And you should learn them from 1 to 15, so you should know all of the square numbers from 1 to 15. So you should know that the answer is 14. So the length, therefore, is 14. So to work out what the perimeter is going to be the distance around the square. So if I draw a square out, we know that each of these lengths are 14. So it's just going to be 14 times 4, which will be 56. So for this question, we just need to pick one of the coordinates. And I'm just going to pick this one here. And we just need to work out what the coordinates are. Well, it's going up in 2, so it's going to be 4 on this side. And this is kind of 4.5, so that's going to be 19 there. So we know it's 19 at the bottom and 4 at the side here. So we're going to have a look on our table for a 4 and a 19. We've got a 19 and 23 here. It's got to be a 4 and a 19, which is here. And it shows that the 4 is for paper 1 and the 19 is for paper 2. So our answer will just be paper 2. So the pass mark for the test is here, and we can see that there are 2 students who passed the test. So it's 2 students out of 2, 3, 4, 5, 6, 7 in total. And we want this as a percentage, so we're going to times it by 100%. So we do 2 over 7 times 100, and that gives us 28.571, blah, blah, blah. and it says it wants it to the nearest percent, so that will be 29%. Another way of writing a to the power of 6 is a times a times a times a times a times a. And another way of writing a to the power of power of 5 is a times a times a times a times a. Now you might notice that altogether there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 a's that are being multiplied together. When you multiply something together 11 times, you get that thing, which is an a, to the power of 11. An easier way of doing this is just adding the powers. So when you've got the same base, which we do here because they're both a, you just add the powers together. We're going to start off by finding what the multiplier will be. So we will start off with 100%, and it's a decrease of 32.6%, so we're going to take that away, and that will leave the percentage as 67.4%. Next we need to convert that into a decimal, so we're going to divide it by 100, and that will make it into a multiplier. And the beauty about a multiplier is all we need to do is get the amount from the question, 486, and times it by the multiplier, and it will do all the hard work for us, and it will give us the answer of 327.56. So to do this question, you just need a piece of paper, a ruler, and a protractor. And the first thing we do is we draw the 11 centimeter line. And my one will not be 11 centimeters for you. It is on my screen, but because depending on what device you watch this on will change obviously its length. And what I'm going to do is I'm going to put my protractor on this end here. So I've kind of got my protractor here. And I'm going to just have a look at getting 39 degrees. Now you've got to be careful because 39 is on the inside, and I'm just going to do a dot. So always look to see which one, the inside or the outside of the protractor, starts at 0, and the inside should start at 0 from this side. And I'm just going to draw a line that connects the end of that line and the dot, like so. Now just you can keep it going. Right, the next thing I'm going to do is put my protractor on the other side. So my protractor is kind of here, and I'm lining up the crosshairs with this point here. But this time I'm measuring on the left hand side, and I'm looking at 59 degrees, which will be here. Get my ruler. Now this time I can actually stop where it hits the other line. So keep going and then stop where it hits the other line. This screen's not perfectly calibrated, so it's difficult to do precise work, something like that. And then what you can do is you can get your rubber and just rub out the extra bit of line that we had to do. And so this is our 39 degrees here, and you don't need to label this on the diagram, but just so we know what we're doing. And it says when it's completed, measure length x. So I'm going to get my ruler out, and I'm going to measure this length here, this one here, and it is about 95 millimeters. So the answer for me is 95 millimeters. Now there is some level of precision. You're not going to get necessarily exactly 95 millimeters. When we mark these questions, we normally have an overlay and we put it over the top, and if it's roughly the same, and you can make small errors because nobody's perfect, and my diagram definitely is not perfect, but there are allowable small errors here and there. A plane of symmetry is anywhere you can cut a three-dimensional shape, in this case a cuboid, and put it up against a mirror and it looks like the original shape. So if we were to cut the cuboid here, and then put it up against a mirror, it would look like the cuboid again. Similarly, if we were to cut it along here, it would look like the original cuboid again. And finally, if we were to cut it up the top here, down, across the bottom here, and then up here, and put it up against a mirror, it would look like the original cuboid again. Now you might think that diagonal ones will work with this. Diagonal ones only work with cubes, not cuboids. So our answer is 3. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us, what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1, 25, and 5, and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So to find the area of a rectangle, we just multiply the width and the length. So that's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared, and then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. So this question says that Adrian, Ben, and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represents plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula, so it'd be half a plus b h, so half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, the next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down. But here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon. And this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. So for this frequency polygon, what we've got to do is work backwards to work out what the table was that created it. So we're going to just draw a starting of a table. And we're going to have our midpoint first, then our like money spent, our intervals, and then our frequency. So the first midpoint is at 40, and we can see here that that was, just get rid of that. That was between, like that was in this group here. So that is 0. And I'm just going to use M for money, 0 to 80, and the frequency is how high it is, which is 10. The next midpoint is here, so that was going to be 120. And we can see that that's between 80 and 160, and the frequency is 20. And finally the last midpoint is here, which is obviously 200. And that is between 160 and 240, and the height of it is going to be 7. So we're looking for the probability customer spent less than 160. So that is these two here. Okay, so there are 30 that are less than 160. And how many are there altogether? Well, it's that 10 plus the 20 plus the 7. So it's going to be over 37. So it's 30 over 37. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of two numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers, just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squareds. And we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450, on the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them, so I cross them both out and put 2 in the middle. We can see they both have a 3 in them, so cross those 3's out and put 3 in the middle. And then 450 has a 3, a 5 and a 5. And 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle. And so the highest common factor will be 6. So we're just going to copy this out first of all. So we've got x equals y over 15. Now we're asked to make y the subject, which means we want y on its own. What's stopping y from being on its own? Well, it's divided by 15. That's what over means. It means divide. So how do we get rid of that divide by 15? Well, we do the inverse or the opposite, which is times 15. So we go times both sides by 15. X times 15 is 15x, and it will get rid of this fraction here and just leave y. So y is 15x. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now in this first group we're not timesing it by 80 to 85 or anything like that, we're timesing it by the midpoint. So our midpoint effectively becomes the t. So we're going to do 15 times that, which will be 1237.5, and we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. The important thing to realise in this question is that we know a female has been selected, so we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out. And we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, that's be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3 over 5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcomes, the outcome here would be male-male, that's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3 over 5 times 2 over 4. And I realise I could cancel 2 over 4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2 over 5 times 3 over 4. So 2 over 5 times 3 over 4, 3/4. That would be 6 over 20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6 over 20 plus 6 over 20. And this is the probability of different, which will be 12 over 20. Now 12 over 20 will cancel to 3 over 5, or 3/5. So this question is asking us to find the probability of not A and B. So if we look at the, and I'm just going to quickly draw out a similar Venn diagram. So if this is A and this is B, then not A will be everywhere apart from A. So it would be all of this here. And if we do the same thing again, and this time we're interested in where B is, so we've got A and B, then B is this part here. So if you have a look and see which are shaded in both, you can see that this part here is shaded in both. So this part here is not in A and is in B. So it's this 3 here. So the probability is going to be that 3 over the total amount. So all of these added together, which is 25. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.